Good morning. Let us study today ultracentrifuge method. What is ultracentrifugation? We will also see the principles and applications of ultracentrifugation method. Then why sedimentation is very fast on rapid spinning of sample centrifugation? Because of centrifugal acceleration is given by the formula omega square r and centrifugal force. There are two methods of ultracentrifuge to determine the molecular weight of macromolecules, polymers, or biological molecules. It is called ultracentrifugation. It is simply rapid spinning of biological or polymer sample. On rapid spinning, the biological samples are taken in these centrifuge tubes. Rapid spinning, on rapid revolution, the different biomolecules, for example, green, there are different biomolecules, DNA, RNA, or mRNA, or different polymers of different molecular weight. Different biomolecules are distributed depending on the molecular weight. The suspended biomolecules or polymers are sedimented or separated and isolated on ultracentrifugation. For example, if you rotate yourself, if you spin yourself, then you will also fall down. You will also fall down. Similarly, on rotating the suspended samples, the suspended particles will fall rapidly, sediment rapidly, and they are by using this method, they are separated. See, they are separated depending on the molecular weight. High molecular weight are at the bottom, whereas the low molecular weight are at the top. They are separated, distributed depending on the molecular weight. This ultracentrifugation method is very much used for biochemical research, for macromolecular research. This method is therefore used to characterize the biomolecules using the molecular weight. To determine, this method is used to determine the molecular weight of biomolecules, biopolymers, etc. Fundamental setup for ultracentrifuge method is shown here. The biological samples are rotated by using rotor as shown here. This is the axis of rotation. This is the sample before centrifugation. These are all suspended molecules, high molecular weight molecules, and this is after centrifugation. The biomolecules or the polymers are deposited or sedimented depending on the molecular weight, where r is the distance between the suspended particle, polymer particle, and the axis of rotation. Okay, now under normal acceleration, of Earth, gravity, the G value is 980 centimeter per second square. The sedimentation rate is very, very slow. Normal gravity of Earth, the sedimentation rate is very, very. However, on rapid spinning, on centrifugation, the rate of sedimentation is very, very fast. Particles will fall down, will settle at the bottom on rapid centrifugation. Why the rate of sedimentation is high on centrifugation? Because of centrifugal acceleration. Because of centrifugal acceleration, because of rapid spinning of sample is increased to 4 lakh times. Therefore, the rate of sedimentation is fast. It occurs in less than second, immediate, in 1 minute or so. This ultracentrifugation method was developed by Swedberg. He was awarded Nobel Prize in the year 1926. For this, Swedberg showed that the sedimentation rate is very much increased by rapid spinning of sample on centrifugation. The centrifugal acceleration is given by the mathematical formula omega square r. Then the centrifugal force is equal to F equal to m into A, where A is centrifugal acceleration. What is omega? Omega is nothing but angular velocity. It is equal to 2 pi n, where n equal to number of rotations or revolutions per minute or per second, that is RPM. Let us calculate, let us solve a problem on rapid spinning, that is 10,000 revolutions per second and r equal to 10 centimeter. What is the centrifugal acceleration? Omega square r equal to 2 pi n whole square r. So 2 into 3.14 into 10,000 whole square into 10. This is approximately 4 into 10 power 8 centimeter per second square. This centrifugal acceleration is 4 lakh times greater than the normal earth acceleration due to gravity. So because of this increased centrifugal acceleration, the rate of sedimentation is considerably increased. Okay. Thank you for watching. We'll continue further. When a biological sample or cell fractions, cell homogenate, is centrifuged, when a polymer sample is centrifuged, high molecular weight settle at the bottom and low molecular weight will be at the top. High molecular weight molecules rapidly move to the periphery and settle at the bottom. Now, a strong beam of light is emerging from strong beam of light is passed through the polymer sample solution to measure the refractive index or absorbance to determine the concentration in this at this distance, and you can also measure concentration at this distance to study the concentration or sedimentation rate. Using ultracentrifuge method, it is possible to determine the molecular weight of macromolecules or polymers. There are two ultracentrifuge methods to determine the molecular weight of polymers. They are sedimentation velocity method and sedimentation equilibrium method. Thank you. We will continue further.